Lesson 5-7, Subtract Expressions. In this lesson, you guys are going to learn how to subtract expressions, keeping in mind that you need to use your property of operations. Take a look at example 1. In this case, we have a pool and a border around that pool. Lida's family wants to put a tiled border around their swimming pool. What expression represents the total area of the border? Well, the first thing that we have to do is we have to use the diagram in order to create expressions that represent both the dimensions of the pool and the dimensions of that tiled border. First, take a look at the dimensions of the pool. One dimension is 2x plus 14, and the other dimension is 14. So the area of the pool can be found by multiplying those two dimensions together, 14 times 2x plus 14. Since the tile border is 2 feet all the way around the pool, then we need to add 2 feet to each edge of the pool, okay, for a total of 18 feet along the bottom side and 2x plus 18 along the side. So there was 2 feet plus the length of the pool plus 2 more feet is a total of 2x plus 18. Now, that area of the pool and the tiled border here represents the total area, but that includes the pool. So in order to find the area of just the tile, we have to take out the area of the pool. So you'll see that right over here along the side. Okay, and we're going to take the total area and subtract the area of the pool. So the area of the entire thing, 18 times 2x plus 18. We're going to take away the area of the pool, which was the 14 times 2x plus 14, where we first have to use our distributive property, and then we're going to combine like terms to get a final expression of 8x plus 128. So in just a second, you're going to see that work. So as you can see from the work here, when you apply the distributive property to the first expression, you get 18 times 2x plus 18 times 18. That expression simplifies to 36x plus 324. That's this piece right here. Okay. When you apply the distributive property to the second expression that represents the area of the pool, you get 14 times 2x plus 14 times 14, or 28x plus 196. That's the second part of the expression. But you notice that there is a subtraction sign here between the two expressions. So remember, when you subtract the expression, you're subtracting everything, which means 36x plus 324 is your first expression, but you're going to take away from that both the 28x and you're going to take away the 196. Now you can combine those like terms in the expressions. 36x minus 28x is where the 8x comes from, and 324 take away 196 equals 128. Now go ahead and do the try it and come back and check your answer. All right, let's take a look at the work here. So I sketched a little picture frame off to the side over here, and you'll notice that the interior picture part, so that's this piece right here, is dimensions of 15 on one side and x on the other. Okay, so that area of just the picture, where the picture goes, is 15 times x. That's the area of the photo right here. Okay. Then we have the area of the frame. Remember, it tells us that the frame is 3 inches wide all the way around. So I've got a 3 added to both the left and the right side of the picture. That's this and this. okay, this and this, and I've got a 3 added to the top and the bottom of the picture. So altogether, this overall height of the frame with the picture in it is 21, and the width of that picture frame is 3 on the left plus x plus another 3, or x plus 6. So when you find the area of the entire thing, you're doing 21 times x plus 6, which is 21x plus 126. Now, to find just the area of the frame, the border of that frame, you have to subtract those two expressions. So we're going to take the entire thing, and we're going to subtract out the area of the picture. And so what you get is a final answer of 6x plus 126. All right, in example 2, we have rational coefficients, but the process that we're using doesn't change anything. Now, one of the things that the book teaches you to do is to think about that subtraction of the second expression as having multiplied everything inside those parentheses by a -1. So you can see how they have changed subtraction to adding a -1. That's this piece right here. And then they distributed that -1 to each of the terms inside. And when you do that, that shows you how to subtract everything from the second expression from the first expression. You can use your calculator to do the computation with your rational numbers, and you end up here with a difference. Go ahead and take a look at the try it. Okay? Remember that the first expression does not change. It's the second expression that you are going to take that subtraction and apply it to each piece inside. In this case, you're going to take away the 99/100ths x, and you're going to take away a -13/100ths. Okay, so again, the first expression doesn't change. But now you can combine your like terms. So try that and come back and check your answer. All right, check your answer to that, try it. And then when you're ready, go down and take a look at example 3. Again, nothing is different there with our process. We just have fractions involved where you might need to get a common denominator before you collect your like terms, or you may need to do some computation with fractions. Don't forget that when you're subtracting, you're either distributing the subtraction sign to every term in the second expression, or you're essentially multiplying each term in the second expression by a -1. When you're ready, take a look at the try it down below. Make sure you distribute your negative or your subtraction sign to each of the terms inside the second expression. And then before you try to solve it, come back and check your work to make sure you're on the right track for that second expression. So pause the video while you do that, and then come back and check your answer. Okay, so there's the subtraction being distributed to each term inside that second expression. So instead of subtracting the entire thing, we're going to subtract the 7 5/10 m. We're going to subtract a -9, which is the same as adding 9, and then we're going to subtract the 4k, which means minus 4k. Now collect your like terms and come back and check your answer. All right, take a look at that try it answer. You should have gotten -3m plus 4k plus 26. On page 312, there are some great hints in the key concept area. Remember that when you write subtraction as addition, you're writing it as adding the opposite, which means you need the opposite of everything inside those parentheses for the second term. That essentially is the same as multiplying everything in that second expression by a -1. You can use that distributive property to think about distributing the minus sign, that subtraction sign, to each of those terms, which essentially changes the sign on those terms. Now I want you to try number 4 and come back and check your answers to A, B, C, and D before you move on. All right, check your answers to A, B, C, and D. To help you out, I went ahead and I rewrote each of the expressions where the negative, or the subtraction sign rather, has been distributed across each term in the second expression, and then I have simplified each of those expressions. I want you to notice in part C of number 4 that after you distribute the subtraction sign to the second expression, you end up getting a -7 plus 7, which equals 0. And when that equals 0, you do not have to show that part of the term. So 4y, take away y, is the 3y. So that's this piece right here. But the -7 and +7, when you put those together, you get 0. Same thing happens in part D, except this time, when you put together a negative w and a positive w, you end up with 0, because no matter what w is, a negative and a positive of the same thing are going to be equal to 0. So all you're doing there is adding your two constant terms, which ends up being 4/10 plus 4/10, which is 8/10. Now on your practice and problem solving page, I want you to take a look at questions 10, 11, 13, 14, and 20. You may try each of those questions separately and then come back and check your answer before moving on to the next question to make sure you're doing them correctly. We'll start with number 10. Pause the video while you try that and come back and check your answer. The key idea coming out of number 10 is that you have two manufacturing plants, each represented by an expression, and you want to know how many more items the first plant produces than the second. How many more indicates that you will be subtracting those expressions. So you can see after I wrote the subtraction of the two expressions that I distributed the subtraction sign to each term inside the second expression. And then I simplified by combining my like terms. So the first plant produces 3x plus 14 more items than the second plant. Now go on and try number 11. Again, pause the video while you try it, and then come back and check your answer. In question 11, company X could be represented by 35 cents plus 5 cents times X, where X stands for the number of minutes. Company Y would be represented by 15 cents plus 4 cents times X. And to find the difference between them, to find out how much more company X charges than company Y, okay, they used N for minutes, I used X, it doesn't matter, then you're subtracting those two expressions, and you're taking the Y expression away from the company X expression. So the difference there is 20 cents plus 1 cent per minute. Now try number 13 and come back and check your answer. All right, take a look at your answer for number 13. $7.65 plus 5 times P represents the amount of money that Jackson spent on fresh fruit, and $2.45 plus 4P represents the amount of money that Tim spent on fresh fruit. And to find the expression that represents how much more Jackson spent, you're going to subtract those two expressions. And when you do that, you find out that Jackson spent $5.20 plus P more on fresh fruit than Tim did. For your last problem, go ahead and try number 20, which is an assessment practice. So here you're trying to be very careful to choose the correct answer, A, B, C, or D. So as you look at the expression that you are simplifying, remember that subtraction between these two expressions represents subtracting the entire second expression. So make sure you distribute that subtraction sign to both terms inside the second expression. Pause the video while you do this, and then come back and check your answer. All right, and here as you can check your answer for question 20, you can see how I distributed the subtraction sign to both terms inside your second expression, inside those parentheses, and then I started grouping together those like terms, Again, use your calculator as a helpful tool there so you're not making any calculation errors. And the correct answer on number 20 should be B, which is negative 55/100 n minus 5/100. All right, I think you're ready now to go ahead and try your 5-7 Math Excel. That is in your Pearson account, and you are welcome to get started as soon as you are ready.